This lesson will cover significant figures, or as I'll call them, Sig Figs. Now, significant figures are the important numbers that tell us accurate information. Now, we've all probably seen this in math or science class. You do a calculation, you type it into your calculator, and your calculator gives you this gigantic number that takes up the entire screen. Well, these are the rules that we're going to use to figure out where to cut that number off. It's very important that you learn to use these rules. We'll use these rules throughout the class. So really go over this. If you don't get it, watch the video again. Do examples of the book. It's very important that you get this stuff. Like I said, we'll be using this for the remainder of the year. Now there's some rules that will help you determine if a number is a sig fig, is one of those important numbers or not. First rule says that all non-zero numbers are sig figs. So 1, 2, 3, and so forth up to 9, any non-zero number, any number that's not a zero, is a sig fig. So in this first example, 54.322, they're all non-zero numbers, so they're all sig figs. That's 5 significant figures. This example has the 2, the 3, the 1. That has 3 sig figs. Next example, 7 sig figs. The 6, the 7, the 9, the 3, the 2, the 1. Those are all significant figures. They're non-zero numbers. Now it's the zeros that get tricky. Sometimes they're sig figs, sometimes they aren't. And the remainder of the rules here, in rule number 2, 3, and 4, will help us figure out if a zero is a sig fig or not. First rule says zeros that are sandwiched between non-zero numbers are sig figs. So, here we have a 0, it's sandwiched between a 6 and a 2. Those are both non-zero numbers, so that is a sig fig. So the 6, the 0, the 2, the 1. That gives us 4 sig figs. Again, that 0 is sandwiched between non-zero numbers, so they're all 3 of them are sig figs. Doesn't matter how many zeros, doesn't matter where the decimal point is, if zeros are sandwiched between non-zero numbers, here all those zeros are between the 4 and the 7, they're all sig figs. Next rule, zeros in front of small numbers are never sig figs. And when I say small numbers, I mean like decimal numbers that are smaller than 1. So we have zeros in front here, they're never sig figs. The only sig figs in this number are the 9 and the 9. Now it's a little confusing. I still have to write those zeros, because if I just wrote 99, that's a very different number, or 0.99, that's a very different number. You have to write the zeros, but they're not considered significant figures. Doesn't matter how many zeros there are. If you have zeros in front, they are never sig figs. So the only sig fig here is the 7. Here, those zeros in front are not sig figs. The 8, the 7, 9, 3, those are all sig figs. But the zeros in front are not. Last rule, zeros at the end or the right side of a number are sig figs only if there's a decimal point written somewhere in the number. Otherwise they aren't sig figs. So in this example, I got zeros to the right, zeros on the right end here. And since there is a decimal point right there, they are sig figs. The next two examples, if you look like the same number. The difference is this one has a decimal point. That decimal point tells us that the zeros are sig figs. Because I got zeros at the right end, on the right side of the number, and a decimal point. They are sig figs. Here, you got 700, but there is no decimal point, so they are not sig figs. 700 without a dot has 1 sig fig. 700 with the dot has 3 sig figs. Again, these rules can be kind of confusing, but they're important. You want to go over them. And you can combine them too. You can have a number that actually has zeros in front and zeros at the end and use different rules to figure out if they're sig figs or not. So I want to explain that last rule a little bit. If I look at a crowd and estimate that there are 400 people, so I go to a pep fest and I say, oh, there's 400 people there. I don't know exactly 400. It could be 401, could be 398, could be 406, whatever. So the way I would write that down is 400 with no decimal point, showing that it only has one sig fig, the 4. Now, if I sat there and I counted every single person in the Pet Fest, and there were exactly 400 people, I would write that differently. I would write that 400 with the decimal point. That shows everybody that I know it's exactly 400. It's not 399. It's not 406. It's exactly 400. That's what that dot tells everybody. So, again, the example 400 without a dot has 1 sig fig. 400 with the dot has 3 sig figs. It's very important you get a good handle on sig figs. We will use them the rest of the year. So now that we know how to figure out if a number is a sig fig or not, we need to apply this to some of the math we'll be doing. So there's 2 main rules for calculations with sig figs. Addition and subtraction. Follow one rule. And the answer should have the same number of decimal places as the starting number with the least number of decimal places. It sounds kind of confusing, but let's look at an example here. If I do this math in my calculator, 7.42 minus 5.6, I get the answer of 1.82. That's what my calculator says. But my calculator doesn't know how to do sig figs. So what I do is I look back at my original numbers. 7.42 has 2 decimal places. 5.6 has 1 decimal place. So I need to choose the number with the least number of decimal places. So 5.6, 1 decimal place. That's what my answer should have, is 1 decimal place. Next example, 4.23 has 2 decimal places. 5.101 has 3 decimal places. I choose the smaller number of decimal places, so 2 decimal places. And that's what my answer should have. So when my calculator says 9.331, I look back at my original numbers and I say, oh, my answer can only have 2 decimal places. So I write my answer with just 2 decimal places. Now if this 1 here was a 5, a 6, a 7, an 8, or a 9, it would round that last 3 up to a 4. So my answer would be 9.34. I'll show you an example of that in a minute. So that's addition and subtraction. Multiplication and division has its own rule. And it says, if you look, it's actually very similar to the addition subtraction rule, except instead of looking at decimal places, we're looking at sig figs. So, example, 3.7 times 4.55, my calculator says 16.835. I look back at my original numbers, 3.7 has 2 sig figs. 4.55 has 3 sig figs. I have to choose 2 sig figs. That says less number of sig figs. So looking back at my starting numbers, 2 sig figs or 3 sig figs, well, my answer should have 2 sig figs. So my 2 most important numbers in my answer are the 1 and the 6. Those are the 2 most important numbers. So those are the ones I need to write. But I always have to look behind my important numbers to see if anything will round up. I look 1 past, I see this 8. The 8 is going to make the 6 round up to a 7. So my final answer is 17. Next example. If you look, we have 3 sig figs here. We have 4 sig figs here. This is our calculator answer, which goes on and on and on. And I have to figure out where to cut it off. Well, here I have 3 sig figs and 4 sig figs. Got to choose the smaller number of sig figs, so 3. So my 3 most important numbers are the 3, the 2, and the 7. Those are my sig figs. Again, I always have to look 1 past my last sig fig to see if that last sig fig rounds up. Here we have a 6, which is going to make that 7 round up to an 8. Because if it's 5 or greater, it rounds up. So my final answer is 3.28. Now the reason for this is your answer can only be as accurate as your least accurate starting number. If you're starting with a very accurate number and a less accurate number, your accuracy depends on that least accurate number. You might know this one really well, the 3.785, but the 12.4, you don't know that number to the same level of accuracy. So your answer should reflect that. Just reminders, rounding rules: if it's less than 5, don't round up, you just cut it off. If it's greater than or equal to 5, you round it up. And you only round the last number of your answer. The exception to that, I should say, is if that last number of your answer is a 9, that will turn it to a 0, and then move the next number to the left up 1. We'll see some examples of that later. And a reminder, addition or subtraction, look at decimal places. Multiplication and division, look at Sig Figs. If you can remember that, you should be good. There's one last thing I want to talk about is, what if your calculation has more than one rule in it? So if we think about this, we have 4.3 minus 7.85 in this example here, times 3.229. Well, here we have subtraction. That has one rule. Here we have multiplication. It has a different rule. So what you want to do is you want to do the math in the parentheses first. So you do the 4.3 minus 7.85. Your answer here for this, you'll want to round to 1 decimal place, because here we have 1 decimal place, 2 decimal places, so 1 decimal place. And then you will take that answer, multiply it by 3.229, and since you're multiplying, you're not going to look at decimal places. For that math, you'll look at Sig Figs. So, combining, it's a little tricky, but there'll be some examples of that on your practice quiz. And that should be it for significant figures.